All right, so this be section 8.6, and this be the third section that we're talking about area between curves. So how is this any different from the last two? Well, in the last two, we would mainly focus on here's a curve and here's a curve, and let's find the area between the two. Now we're looking at areas where we have maybe several intersections going on, and we have to take that into account. What this is going to look like is a cubic. It looks a little something like this. What this is going to look like is a parabola looks a little something like this. And when stuff like that happens, we notice, oh, wait a minute, there's two areas, that we have to find out. And so we're going to label you an A, we're going to label you a B, and we're going to label you a C. And what we're going to have to do is we're going to have to find the integral from A to B of the one, and then the integral from B to C of the other. And what could potentially happen is, yeah, it's going to be the same formula every time, but we have to keep in mind that we're doing like the absolute value. So maybe if we do it the exact same way each time, we'll get a positive area for one and a negative area for the other. But we have to keep in mind that we're talking about the areas in between curves, not above or below the x-axis. So this is going to be our process here. So problem one is find the x values of the points of intersection and label them from smallest to largest A, B to C. So we're going to walk through this process step by step. The way you find the areas of intersection or the points of intersection is you set the two equations equal to each other. 2x cubed minus x squared minus 7x equals x squared plus 5x. Okay. Let's subtract x squared, subtract x squared. Let's subtract 5x, subtract 5x. You go away, and you're left with 2x cubed minus 2x squared minus 12x equals that. We can factor out a 2 and an x, and that leaves us with 2x times x squared minus x minus 6. Set that equal to 0. And we have 2x, factor that out to x minus 3, x plus 2. So using the zero product property, our magic numbers are going to be 2x equals 0 gives us a 0, x minus 3 equals 0 gives us a positive 3, and x plus 2 equals 0 gives us a negative 2. So from least to greatest, we've got negative 2, 0, and 3. Set up the integrals for the area between the curves. All right, so what I'm going to do is I'm going to set up from A to B would be from negative 2 to 0, and we just take one minus the other. Now, if my picture is accurate, in this case, the upper curve is going to be the cubic. Again, not that it matters. If for some reason I were to do u minus u, I'd get a negative and I'd just make it positive anyway. But I'm going to try to be consistent. And so this guy is going to be 2x cubed minus x squared minus 7x. Minus that whole guy right there, x squared plus 5x, close it, dx. And then on top of that, we're going to add the next integral, which is going to be us integrating from 0 to 3, and if this picture is accurate, we've got the parabola on top this time. So we're going to do x squared plus 5x minus parentheses 2x cubed minus x squared minus 7x, close it, bracket it, dx. Now it looks like for this problem all we need to worry about is just the setup and not actually doing the problem. So we're not going to do the problem because I don't have all the space in the world, and I'm going to have like other videos where I actually do the problem. So we're going to leave this like that. But yeah, this is what you would do. And if for some reason I set this up incorrectly and I got negative areas for either of them, make them positive. And when you're done, you add them both up and you get your area between those curves. Hope this helps. Find the total area bounded by the curves y equals negative 1/2 x cubed plus 2x squared and y equals 4x minus x squared. What we're looking at is a negative cubic, so it's going to look something like this. And what we're also looking at here is an upside down parabola. It's going to look something like this. Now, when we do problems like this, and keep in mind, my picture is probably completely inaccurate, but that's all right. When we do problems like this, we're not looking just for an area between the curves. What's going to happen is we're going to have two areas. So we're going to have to do two separate integrals once we find our points of intersection, two separate integrals. and hopefully get positive answers for both. If we don't, make it positive, no big deal, and then just add them up. So what I need to do is I need to find out what my points of intersection are. And the way that I do that is by setting these guys equal to each other and solving for x. So we have negative 1/2 x cubed plus 2x squared equals y equals 4x minus x squared. Now, this is just going to be a gross mess, and what I'm going to do to start off is I'm going to multiply everything by negative 2, because I kind of know what's going to happen if my job is to solve. I'm going to see a lot of factoring, and I don't want to deal with the negative 1/2. So if I multiply both sides by negative 2, that makes you positive x cubed minus 4x squared. That's going to be minus 8 plus 2x squared. Now let's move everything to the left. Move everything to the left. Let's add 8. Add 8. Let's minus 2x squared. Minus 2x squared. That goes away, and you're left with just 0 on the right. X cubed minus 6x squared plus 8. X. Oh my gosh, why did I not notice that? Plus 8x. Sorry, everybody. Ooh, I'm not going back and editing. Leave it alone. What can I do? Well, I can factor out an x. And when I factor out an x, that leaves me with x squared minus 6x minus plus 8 equals 0. That factors out to x minus 4 minus 2. So my magic numbers, and therefore my points of intersection, are going to be 0, 4, and 2. So 0, 2, and 4 in that order. All right, now I'm going to set up my integrals. Okay, and I'm going to do integral, I'm just going to set them up, I'm going to write everything out. Integral number 1 is going to be from 0 to 2, and according to my rough draft, I'm hoping that the parabola is the one on top and the cubic is the one on the bottom. If I'm wrong, then nothing major is going to happen. I'm just going to have myself a negative area, and I need to make it positive, no big deal. So let's do the parabola. So 4x minus x squared minus negative 1/2 x cubed plus 2x squared dx. So let's set that up that way. The other one is going to be the integral from 2 to 4 of, let's go the opposite way. Let's put the cubic first. So we've got negative 1/2 x cubed plus 2x squared minus parentheses 4x minus x squared, close it, dx, donezo. All right, now we integrate each one. Fortunately, and you know, it would have been nice if I just kept them the same. It's too late. Let's just do the one on the left first. Let's do one on the left first. First thing we're going to do is distribute that negative. We're not even going to integrate yet. 4x minus x squared plus 1/2 x cubed minus 2x squared dx. All right, we can combine like terms here. So from 0 to 2 of 4x, u and u combine to make negative 3x squared plus 1/2 x cubed dx. All right, I had to stop the video and restart because real life happened. But here I am. I'm at this point right here where I have to integrate u. And integrating from 0 to 2 is going to leave me with 2x squared. What is that? Minus, just an x cubed plus 1/4. So 1/8 x to the 4th limits at 0 and 2. Now this is going to be kind of nice because the first one, I mean, the math is not going to be super bad like the movie. Remember that movie? I have more space over here, so I'm just going to scooch this over here. I have 4 times, nope, I'm looking at the wrong thing. 2 times, this video is not starting out well. 2 squared minus 2 cubed. That's supposed to be a 3 plus 1/8 2 to the 4th, close it, minus, I'll just get 0 because if I plug in 0, I'll get 0, so we'll leave that as that. Okay, let's make life easy. U will become 2 squared times 2 is going to be 8 minus, oh, no way, 2 to the 3rd, which is 8. Oh, how about that? Plus 1/8 times 16. So we're just going to get 2. Look at that. All right. So you become 2. So this little chunk right here is going to be 2. Now let's do this guy. A lot of similarities going on. A lot of similarities going on. You can distribute that negative, so you become from 2 to 4 of x cubed plus 2x squared minus 4x plus x squared, close it, dx it. You become negative 1/2 x cubed. These guys combine to make plus 3x squared minus 4x, close it, dx it. And now when I integrate, I get a lot of similarities over here. This becomes negative 1/8 x to the 4th plus x cubed minus 2x squared, limits at 0 and 2. Nope, limits at 2 and 4. Let's get the smaller version of the eraser. There we go. Look at me being smart and learning from my mistakes. All right. So this ain't going to be pretty. I got negative 1/8 4 to the 4th plus 4 cubed minus 2 times 4 squared, close it, minus it. And then I already kind of know what's going to happen here. But I'm not going to do it. I'm not going to do it that way. Negative 1/8 2 to the 4th plus 2 cubed minus 2 squared, close it. All right. Let me see. We are going to end up with 4 to the 4th is 256. And then negative 1/8 of that is negative 32. Okay. Plus 64. 4 squared is 16 times negative. Oh, no way. No flippin' way. Nice. You just go away. How about that? Minus negative. So 2 to the 4th power is 16. So negative 1/8 of that is negative 2 plus 8. 2 squared is 4, but minus 8. So you get negative negative 2, which is also 2. So that guy became 2. That guy became 2. Last time I checked, 2 plus 2 is 4. Thanks for watching. Find the total area bounded by the curves y equals sine x and y equals 1 on the interval 0 to pi. So let's draw out what sine x normally looks like. Find the total area bounded by the curves y equals sine x and y equals 1 on the interval 0 to pi. This is me getting ready to draw out sine x. Looks like this. And it stops there at 2 pi. Peaks out at 1. So I care about this stuff going on right here. So I care about the area here from 0 to whatever u is, and from whatever u is to 2 pi. Okay, so I need to find what that guy is right there. Well, how do I find out what that guy is right there? Well, we set sine x equal to 1. To get x all by itself, if you're wondering, why all that space? So I can do this, baby. So I can inverse sine 1. And as you know from pre-calculus, the inverse sine of 1 is pi over 2. Okay, right there at 90 degrees, pi over 2. So you are my limit of integration for one of them and my limit of integration for the other. All right. Now I'm going to run into a fun little happy accident, but I'm going to pretend like that won't happen. I'm going to set up two integrals, and in both cases, y equals 1 appears on top. So one integral is going to be from 0 to pi over 2 of 1 minus sine x dx plus pi over 2 to 2 pi of 1 minus sine x dx. And at this point, you should realize, well, wait a minute. It's the same guy. Why not combine the two integrals into one whole integral and do from 0 to 2 pi of 1 minus sine x? Well, that's exactly what we're going to do. And the reason why that happens is because there's no upside down stuff going on. There's no upside down thing that I have to worry about. In both of these cases, y equals 1 is the top thing. There just happens to be a little sliver in between where it stops. And you have no area because the two lines intersect. So we're not going to lose sleep over that. The integral of 1 is x. The integral of sine x is cos x, so negative negative cos x is positive cos x. And my limits are 0 and 2 pi. So once I set this up, I get 2 pi plus cos 2 pi minus 0 plus cos 0. 2 pi is 2 pi. Cos 2 pi is going to be 1, so plus 1, minus 0 is 0, so get rid of it. Cos 0 is also 1. So this gets us 2 pi plus 1 minus 1, which is 2 pi. And that's how we do it.